In the next position, I have your paste copy. I'll do it. I'll put all the set of diagrams. In the next position, the slab will come to this position. It will have maximum kinetic energy. Am I right? And there won't be any force. Because it will accelerate, no? And it was at t equals 0, we have started here. And this will be t equal to t by 4. Sir, how that will see this? The next one. In the next position, what is the state of slab? Now the slab starts decelerating, no? Yeah, it'll be like this. Yeah, sufficient length is there. So it will start decelerating. How the force will act? Now the force will act in opposite direction. There'll be retardation. K1 you call kinetic energy. K is a kinetic energy of K is a slab dielectric constant. Here K max, K1 are kinetic energy. It will undergo retardation. Then finally it will come to rest. Instantaneous rest, better you call. My job is very easy. Paste copy. Okay, yeah. This is so. Next part will be where do it will come to rest? What length of slab will be there between the plates? Anybody wants to answer? Yeah. I want answer from anybody. What length will be there? So this will become some intermediate time. This I'll put it t by 2. Now what length of the slab will be there between the plates? Means same x length. Okay, agree this. Instantaneous rest. Then again this force will act, will pull it back. Again we'll get back the situation. But here how the kinetic energy of the slab will be? The maximum kinetic energy, because the force was acting, no? So here it will be K max. This will become T equal to 3T by 4. After this, finally, it will return back to this original position. I think the whole situation I'm showing at one page only. Do make notice here. No. Finally, it will come back to like this. Is it oscillatory motion or is it SHM? That's what primary we have to ask ourselves a question. Okay, there's a maximum kinetic energy. Then instantaneous rest. Okay, this will become one time period. Then again, so here, so I had to show one more position where it will be like this. It will undergo retardation. Then it will be. I think I'll show that. So it will be this position. It will come. No, when it comes this position, it will undergo. Oh. There are some around 16 different types of questions are there. Try to work out them. So this will be the some kinetic energy K2. Here the force will be in this direction. Finally, it will undergo retardation and will come to this position. This will T equal to 0 altogether. T equal to capital T will 90. This is some intermediate time. No, so many questions are here. Will they be generated? First primary question. Then what about the current? Will it oscillate here also? Current direction also will change, or will it remain fixed here? So the first will start from here. The moment I release the slab between the plates, some x length of slab between the plates, so it will start accelerating. Capacitance will increase. Potential difference constant, capacity increases, charge should increase. So these are the logical thinking. Please do bring across capacitor. If E constant, C increases, Q should increase. So from where that additional charge will come? From the cell. Okay, tell me like now, as it starts accelerating, so how the charge will flow in this direction? There'll be flow of current here. So if in fact you have to show it here, there's a current and the charge will flow here. Then afterwards, it has come fully between the plates of capacitor. Here it has come fully between the plates of capacitor. Now the maximum kinetic energy is there. Now, because of maximum kinetic inertial motion, it starts moving towards left. Then as it starts moving towards left, capacitance decreases here. Then charge should decrease. So how the charge now, the same current has to flow here. It will come to instantaneous rest. Slab will come to instantaneous rest. Then again as it starts moving, then again the charge how it will flow in this direction. So now you can look at this. here again what's happening to it. I show intermediate, one more diagram is needed, no? Here. Coming here. I'll bring one more diagram. Many students are asking, sir. Oh, I'm really got stuck. I'll adjust the diagram, no problem. Slightly, we have to move the slab. Intermediate diagram, no? I think diagram. Yeah, this will be more justified before reaching. No, clearly you see it. And now this will be some kinetic energy. It will be there. So how the current in fact will flow here. If you let there be. So I'm going to starting some initial current is flowing. Okay, therefore I am avoiding it. Okay, this will be the current. This will be the charge. This will not be T/4, time less than T/4. Here it will have some kinetic energy. Hope everyone is able to understand things. So when the slab moves from extreme to mean position, the current will flow from, the charge will flow from the cell to the capacitor. When it's moving again from the mean to left extreme, the charge will flow in opposite cells. So in this way, what's happening there? What conditions are arising? There'll be exchange of energy between the cell and capacitor. There's exchange of energy and no heat generated. This is the ideal we are discussing. Practically, the conducting wires will have a resistance. So there are so many complications are there. There'll be friction between the plates and capacitor. We are discussing ideal world, paper world. What was our question? We wanted to, we are not here artists, no, to draw a diagram. We were interested to get the time period, how to bring time period. How to bring the time period. What time, if I can calculate this t by 4, okay, no, afterwards 4 times of that time period. So can we calculate this time taken to move from, like from in the t by 4, can we calculate this one? So what was the, how much of distance the slab will move to come fully between the plates? Look at this first and third diagram. X length of slab was here. Look at only this edge. How much of distance it will move to fully between the plates? L minus x. And what is the acceleration? Constant, because constant force will act. No? In all the cases, you just show F is acting. Here, what about force, sir? Sir, can you say anything about force? No force will act here because the fringing effect will be somewhere in this way. It is not fully between the plates. No, here force F will not act. Now, because of kinetic energy, it will start moving out of the plates of capacitor. Then capacitor decrease. The charge will flow in this way here. Here, what about how to show the charges? I think here. Okay, this is again, it should be in this direction. Some good conceptual questions will ask. That's why I'm interested. I'm showing all the diagrams, charge flow, everything. Now let's get into our calculation part. L minus x equal to a t by 4 whole square of a t by 4 whole square. So x is a given thing. So x can be anything in length. So do we know acceleration? So what is acceleration? You can write it as F by m. Directly, I'll bring this expression. The next step, we'll write it here. L minus x equal to, already this 1 by 2 I had to adjust, no? In place of a, it will become md t square by 16. Okay, now solve for t to get the required answer. Hope everyone, I'm trying to put everything in one diagram. When the kinetic energy of slab will be maximum, when at mean position. So you have to call this as a mean position. This again, mean position. So I want that maximum kinetic energy. Can we calculate that maximum kinetic energy? Yes, you can calculate. You know acceleration. Then v square minus u square equal to 2a formula you apply it. You get that maximum kinetic energy. Let me solve for that t. So the total t will be is equal to 2 16 4 ja 64 L minus x md by f naught L e square minus k1. The time period depends on applied EMF. Time period depends on applied EMF. The answer is no. S. Time period depends upon the x length of slab between the plates. Yes, it is. Because if you make x equal to L by 3, you'll get one time period. If you put x equal to L by 4, you'll get one time period. Try to see this. I think based on this equation, we have to analyze here. There's one very famous, this numerical is there. Possibility of asking as it is in advanced exam. Okay, after this, we'll go for the next one. Anybody having doubt, you can ask. So many conceptual things are there. What about the current, all other things? What about the current here? Constant or variable current? Current flowing to the circuit. Current I is constant.